Welcome. In this video I'll be talking about a sinusoidal modem signal and the smallest transmission period and the data rate. So when dealing with a sinusoidal signal in a modem, it is important to understand the relationship between the signal frequency, the transmission period, and the data rate. The signal is represented as follows. X of t equal to a sine 2 pi f t. A is the amplitude, f is the frequency, t is the period. So what would be, so one question when you're talking about that a modem signal is, what would be the smallest transmission period? The transmission period t is the time required to complete one full cycle of the waveform. So this will be one full cycle of the waveform. The smallest transmission period t that is good for a given frequency f can be determined using the relationship between the frequency and the period. The period t is the reciprocal of the frequency, so we would use something, so it would be period equals 1 over the frequency. So this equation shows that the smallest transmission period for a signal of frequency f is simply the inverse of the frequency. This period ensures that the signal completes exactly one cycle within the given time frame. So remember that f is in hertz and t is in seconds. So if you're given a frequency, you can find the smallest transmission period. Now let's talk about the data rate derivation. The data rate, often referred to as the bit rate, so sometimes we call it the bit rate, is the rate at which data is transmitted over a communication channel. It is typically measured in bits per second. In digital, so we measure in bits per second. In digital communication, the data rate can be derived from the frequency of the signal and the number of bits transmitted per cycle. So we can say that for a modem signal, the data rate can be expressed as rate equal to frequency times n, where n is the number of bits per number of bits per symbol or cycle. Let me give you one example of how to compute the data rate. So let's say you have a modem. A modem uses a frequency of 1000 hertz. So F is equal to 1000 hertz, and each cycle transmits 2 bits. So N is equal to 2 bits. The data. So what would the data rate? What would the data rate be? For that, we use the formula R is equal to frequency times N. So it will be 1000 hertz times 2 bits. That's equal to 2000 bits per second. This calculation provides a framework for understanding how the frequency and symbol rate impact the overall data rate of a communication system. Adjusting either the frequency or the number of bits per cycle can directly influence the speed of the data transmission. So adjusting frequency or number of bits per cycle can directly influence the speed of the data transmission. In the next video, I'll be talking about a modem with data rate with multiple amplitude levels. Thank you for watching. Please subscribe.